Welcome to the club. This is meeting 166, and today is the 5th of October 2023. We start with a bit of feedback from Roy Barkan on the previous episode regarding erroneous behavior. He writes, I think the erroneous behavior proposal is meant to allow the standard to specify situations where it is allowed to either fail on or to allow but be deterministic if it allows the situation. To try and clarify, here are various situations that the standard describes. Ill-formed, compilation must fail. Undefined behavior, compilation must succeed, compiler might warn, but code can do anything. The third one, ill-formed, no diagnostics required, the dreaded if-NDR. Compilation is allowed to fail or generate code that can do anything, basically without warning you. And the fourth one, the new one, is erroneous behavior. Compilation is allowed to fail or generate deterministic, not explode, behavior. So thanks to Roy Barkan for the clarification, although how it all plays out in the end is still a bit murky, how these four can coexist together.
I must say, I was a bit confused by this, but I'm warming up to the idea. If we manage to get into a situation where people would get less worried about using C++, because at least there is some, there is not going to be undefined behavior, there's going to be erroneous behavior, but I mean the missiles won't launch and bad things will not necessarily happen, then maybe it's a good thing. And there is some more, I've seen some more proposals building on top of this. So I'm open to the ideas. I still think we'll need to explain this to newcomers, and it's going to be adding to the complexity, but maybe it solves more problems than it creates.
Yeah, anything potentially improving the situation with undefined behavior is good. Next topic is the committee mailing for September 2023. There's quite a few papers. Let me go through some of them. Unfortunately, as a spoiler alert, there's nothing on reflection or pattern matching. Boo. This paper is called Vector API for Random Number Generation. This is at revision 9, so it's been brewing for quite a while. And it's a convenience, I guess, improvement. In the motivation and scope, they say the C++11 random number API is essentially a scalar one. Stateful nature and the scalar definition of underlying algorithms prevent auto-vectorization by the compiler. So this paper proposes a new interface, which is basically an equivalent of generating random numbers in a loop, but it allows for better vectorization and better convenience. So the proposed API is a member of stud ranges namespace, and it's called generate_random, where you create a random number engine, set it up, saying you need, for example, uniform real distribution, and then pass those parameters to generate random together with an array of floats, for example, of certain length, and it fills that array with random numbers. And the paper also added iterator-based versions for when you don't have ranges. Yeah, that sounds good. Next paper on my list is related to contracts. It's titled A Natural Syntax for Contracts by Jens Marer and Timo Domler. I must say, it's a clever title. When you call something a natural syntax, it kind of prepares your brain for accepting it as something completely natural. This is different from the previously proposed syntax, which is attribute-like. And this one looks like a function or concept. Again, they use the same sort of keywords, pre, post, and assert. I think there is an assert somewhere in the paper. But it looks pretty much exactly like attributes, but instead of using attribute-like syntax, you use sort of a statement, or it's not a function, it's like more like a statement. Pre, parentheses, condition in the parentheses close, semicolon. And after the function signature, you have a series of those preconditions and postconditions. And you also can...
It seems like they want to keep this fairly short, like they don't intend contracts to be massive amount of code, just something that you can put in a quick line.
Yeah. Actually, that's a good point. All the contract-related papers illustrate contract conditions as something short. Yeah. It would be dreadful to see the code where a condition spans pages of code. Although I'm sure someone's going to write that.
And this syntax kind of disencourages that, because you don't have curly braces, you have normal brackets, round brackets, so that makes it kind of look like, it shouldn't be too much code there. But yeah, and does it introduce a scope in a way? I've seen this syntax with the columns somewhere. It's an interesting take, I think.
And they say, quote, "This order is consistent with the natural order of reading a function declaration. Typically, the reader will first want to see the function signature and whether it's virtual, then any compile time constraints, the requires clause, and finally, any runtime constraints, the contract checking annotations." So that's the explanation of the natural word. The next paper is also contracts related. It's titled "A Principled Approach to Open Design Questions for Contracts" by Joshua Byrne. So this is like a summary of the approach and a list of open questions for the contract's MVP, minimum viable proposal. Quote, "SG21 has made significant progress toward producing a complete design for a contracts facility MVP. As work proceeds for completing this feature proposal, open questions must be considered and answered such that the feature will eventually have widespread adoption throughout the entire C++ ecosystem. Fundamental design principles that help guide such decisions for the contracts facility are presented in this paper, as are proposals that address most, if not all, of the open questions affecting the design of the contracts facility MVP." In the introduction, they summarize the other papers with links, which is convenient. And then they list principles and yeah, basically all kinds of stuff about the current state of things in the MVP. I must admit, I only skimmed this paper. Quote, "The contracts MVP being developed by SG21 is progressing smoothly towards a complete proposal according to the agreed upon schedule." Hold that thought. The next paper, 48 pages long, by Joshua Byrne, Jake Fivold, and John Lakers. And it's titled "A Bold Plan for a Complete Contracts Facility." I'm not actually sure. This looks like a complete thing. And I'm not sure if it builds on the MVP work or it's something like separate. The previous paper was written by Joshua Byrne, and he's also one of the co-authors of this one. So I'm guessing this builds on the MVP. But given the previous quote, I mean, it happened before when the existing work was suddenly, how should I say it? Well, previously existing work was derailed by a new paper. And I wouldn't be completely surprised if it happened again. But yeah, this is interesting, actually. I will need to read that paper more thoroughly. At the moment, I've just skimmed it. And given that it's from Bloomberg, it could be that they apply their own requirements to the existing work, so that contracts that get into C++ will be tailored more towards their situation. But interestingly, there's a chapter called Syntax, and they list both proposed syntaxes, the attribute-like syntax and the natural syntax. And they say, quote, "Until a final choice is made on the syntax for contracts, this paper will use the alternate attribute-like syntax and will include footnotes where a significant deviation with the other syntax choices is worth noting." And the alternate attribute-like syntax. So a third one then. Sure, why not? Yeah, anyway, I thought it was interesting that this paper suddenly appeared in such a complete form.
Maybe it's a good sign. Maybe, as you pointed out, one of the authors are the same. So maybe there is some convergence. Maybe the completeness of this paper means that we are getting closer.
I should hope so. I would really like there not to be a repeat of the previous situation with contracts.
Yeah, we've been burned before.
Yeah. So yeah, okay, we'll watch this one. This is at revision 0, so anything can happen. We need to see what will the committee feedback be. Next paper is titled "A Plan for C++ 26 Ranges" by Barry Revzin, Connor Hextra, and Tim Song. And it's a plan. It summarizes the current proposed features, current papers in flight. There's a big table which summarizes things that were already implemented, including in range v3 library, which is not standard. So yeah, it's a very useful summary and explanation of what's coming in the future. So yeah, it's a very useful paper. Next paper is titled "Sender-Receiver Interface for Networking." It's at revision 1. We've seen it before. It's by Dietmar Kuhl of Bloomberg. And if you remember a thing called networking TS, this is sort of a rebase of networking TS on state execution proposal. Not rebase as such, but let's see what the intro says. Quote, "This document proposes the addition of senders for asynchronous networking operations to the networking TS and ultimately to the C++ standard. As the state execution proposal isn't landed yet, this proposal is kept at a high level and is primarily intended to discuss what a potential interface for asynchronous networking operations could look like." So this is sort of a paper to maintain the ground for eventual introduction of senders and receivers into a future version of networking TS. Have I got that right? Hopefully. The proposed quote, the proposed changes augment the networking TS rather than defining entirely new networking components. The main dispute over the networking TS is the model for asynchronous execution. The vocabulary used to interact with networking facilities like addresses, socket, protocols, etc. doesn't need to be replaced entirely to support sender-receiver. The sender-receiver capabilities can be added, which is what the current proposal does. If the current direction of having only one model for asynchronous operations is confirmed, it will need to also remove the executor-based facilities. So it's like a work in progress to facilitate the future development of networking TS once senders and receivers are complete, whenever that happens, which is, I think, good and a noble endeavor. And let it continue, because otherwise we'll never get any networking in the standard, which some people think would be a good thing. I would probably like to have it in the standard.
Agree.
The next paper is about erroneous behavior again, and it's a new proposal for adding a new type of erroneous behavior. The title is Erroneous Behavior for Missing Return from Assignment. So it's kind of a small one. The motivation section says, flowing off the end of an assignment operator overload is a common mistake. In current C++, unlike in C, it's undefined behavior to call a function with non-void return type that flows off the end, regardless of whether the result of the function call is used. P2795 proposes the definition of erroneous behavior in C++, which is well-defined behavior that is nonetheless an error.
This is the proposal that kind of softened me on erroneous behavior concept, because, yeah, I mean, it's a new thing, and as new thing, it requires new training. But it does seem to solve some issues. Here, for instance, avoiding undefined behavior again. Maybe it's not bad.
Yeah. This one definitely sounds like a good thing. Although you should probably use default implementations for things like this. But yeah, I completely understand that there is a
maybe it was a bit of a contrived example. But
yeah. So yeah, that's good. The next paper is by Walter E. Brown, and it's called Implication for C++. Looking at the title, I thought it would be something pretty grand. It's like, what is the implication for C++?
Yeah, it's a good title.
It's a good title. However, this is about proposing a new operator. This paper proposes to introduce operator equals greater than, or arrow, the implication operator into the C++ core language. And then the paper explains what is implication. And it's just another kind of logical operation. Think if you have two booleans, P and Q. So the semantics of the proposed operator is identical to not P in parentheses or logical or Q. There are truth tables to illustrate this. And yeah, lots of interesting words like if antecedent, then consequent.
Yeah, I was reading this. It took me a minute to figure out, the logic behind. But the more I read it, the more I liked it. At the beginning, I must confess I was a bit puzzled. But Walter Brown is a master metaprogrammer. So I was trying to keep an open mind, and in fact, later on in the paper there are examples where this thing is useful in static asserts. And yeah, I mean, the logic is just having some sort of operator that states if something is true, then something else also must be true, ignoring every case where the first thing is not true. If the first thing is not true, then whatever, then everything is fine. But if the first one is true, then the second thing must also be true. It makes sense. Again, I don't know if we want to go and add even more stuff like that. But if Walter Brown says it's useful, I'm willing to keep an open mind.
Yeah, the paper is very well written, and the language is just really nice to read. And I've written quite a few of those exact conditions in my code, or seen in other people's code. But as for the operator being introduced, I can't shake the feeling that it's a waste of a perfectly good arrow operator.
You would like this nice arrow to be used in some other way.
Give me short lambdas.
Right.
Short lambdas.
Yeah, then it's a syntax problem.
Can you use something else? Some other double thing? I don't know. Anyway. It's interesting if there's going to be any bike shedding about what exact operator to use for this. And
Probably.
Historically, C++ is very new operator averse. So yeah, we'll see.
Yeah, I believe the reason behind using an arrow is that in mathematics, an implication is actually denoted as an arrow, a right-pointing arrow. So this is kind of a logical thing, but the thin arrow is already used for pointers.
Right, I'm exposing my ignorance here. Thanks.
Maybe we could have equal, then straight line like a pipe, and then greater than to make into a more complete but longer to type arrow. I don't know.
Or double minus and greater than, or whatever. Yeah, but it would be probably error prone or ambiguous to parse.
Yeah, double minus is also a problem because you get this. You remember a few weeks ago, Gleb, you showed us the double minus greater than in a while loop. There was like something going to zero.
Yeah, that's
the goes to operator. Yes, operators are hard. Right. Next, someone on Reddit says, question, is SG7 reflection is still active? And the answer, unfortunately, is no. Someone replies, I'm not very informed, but I read on previous Reddit posts that the author of reflection papers had some more important stuff come up. So there's no one to push the reflection papers for now. And yeah, someone posted earlier that the forums and I think mailing lists are completely silent.
It's a very sad, very sad story, yes.
So we might not even get it in 26. Next topic is CMake. And it gets C++ module support at last in version 3.28. I kind of feel that this warrants a bigger version increase, given that it's such a huge feature. It's like 27, no modules, 28 modules. 3.3 maybe at least.
I'm looking forward to using this.
Quote, after 5 years, it's finally done. Next CMake 3.28 release will support CPP modules. C++20 named modules are now supported by Ninja generators and the Visual Studio generators for Visual Studio 2022 and newer. In combination with the MSVC 14.34 toolset provided with Visual Studio 17.4, nice version numbers there, Visual Studio, and newer, LLVM Clang 16 and newer, and GCC 14. After the 2023 0920 daily bump and newer. So GCC module support hasn't even warranted a new version number or anything. It's like, this is the commit, use it for modules. But yeah, at last, well done everyone involved in this. I'm really glad to see it. Maybe now people will start using it, using modules at last.
Is there support for import std on any of the compilers? I think maybe is
MSVC. I think yes. Others, I'm not sure. I think
maybe this GCC 14
GCC has it
a couple of weeks ago.
Yeah, but Clang, I don't think it has it yet. I don't know. I'm not sure. So, yeah, and then the rest of the thread on Reddit is about how bad CMake is. Like, I had this shower thought the other day. CMake is the PHP of build systems. PHP is notoriously badly designed as a language, but everyone uses it, and I dare say so is CMake. Right. Another modules-related thing, Gabidos Reyes writes on the Visual Studio blog, open sourcing IFC SDK for C++ modules. Yeah, quote, today we are thrilled to announce the availability of the IFC SDK, a Microsoft implementation of the IFC specification. This is an open source project under the Apache license. The IFC specification formalizes C++ programs as data amenable to semantics-based manipulation. So this is what describes the format of the BMI, built module interface. This is like an intermediate representation of a C++ program. And he hopes that other compilers will adopt it and potentially will support the same BMI format. Currently, both GCC and Clang, I think, have their own format for storing pre-built modules, module binary interfaces. But I think even if they don't adopt it, there may be some useful tidbits there for the other compilers to implement or just have to look at. Right. Next topic is Hubsata's Cppfront Autumn update. Cppfront is Cppfront is the compiler for Herb's CPP2 language. And in his blog post, he says that the compiler started self-hosting. So it's interesting. He says, I haven't spent a lot of time yet converting Cppfront's own code from today's syntax 1 to my alternate syntax 2, which I'm calling CPP1 and CPP2 for short. So there are now 2 CPP2 syntaxes? Or does he mean that CPP1 is just standard C++? it's not. It's not yet. It's not clear to me. I think he just calls it.
I believe it's just his own evolution of C++, version 1 and version 2, some improvements he made.
Right. Yeah. Maybe.
But maybe it is confusing. Maybe CPP1 just does mean normal CPP.
Why not?
That would be CPP0. We are in the C world.
So next he says, no data left behind, mandatory explicit discard. So in CPP2, no discard is now the default, including when calling existing C++ libraries. So he's just appending no discard to basically everything. He says it's pretty painless, and his proposed way to do an explicit discard is to assign the result to the don't care wildcard, the underscore. We do have stdignore.
I don't know if stdignore is only sanctioned to be used with std tie in principle, and it's a little bit used as an underscore here and there. But I do think there were proposals to standardize the underscore in a similar way. I remember well.
Yeah. I think the underscore is in C++23, but it sort of works as a normal variable. You can only have one in one scope.
Mm-hmm. And
whereas
here
you can,
I wonder.
Yeah, good question. Stdignore you can use however many times you like. I used it outside the std_tie context, so I don't know.
I've seen it, in many places as well, but I'm not 100% sure that it's not a slight quote-unquote misuse of standard ignore.
So CPP2 has in-out and out parameters, and this leads to his explanation of how the optimization works with Cppfront when it has to determine which usage of a variable in a scope is the last one, so that it can perform an efficient move, for example. And here he says he presents a piece of code which assigns something to a local variable, and then passes that variable into a function. But basically, if you don't then assign the x to a don't care variable, the compiler might think that the function call is the last usage and might over-optimize or something. So you sort of have to assign it to the underscore, and the assignment has to be the last operation in a scope, which looks to me like there's additional nuance that you have to keep in mind. And
and those two things are you need to do in a different line, something that maybe it could be done in one. I don't know. I mean, if you do std move when you call function, then okay, so that's it. In this case, you advance and then you set underscore to it. I mean, it does look like a two-phase process. I'm not sure I understand it.
Could it be related to exceptions? In line 4, you actually destroy the X. If you have some code in between and some exception happen, you will have to destroy X with other variables at the end of the scope. So if you have some exception after line 4, in this case, X already destroyed and it could be optimized better.
Could
Well,
be.
Depends
well,
on the
moving-
definition of destroyed. I don't know here if we have the usual C++ understanding of what things, what destroying means. You know.
I mean, it's called destructor for the vector.
So
No.
the destructor of this x variable would still probably call that line, you know, when the scope ends, I guess. Although
No,
I'm not
if
sure
if
because
it
there is
if
a
it
signal
if it
here.
should go away at the end of the scope, it means if you will have something in between and it created an exception, and at the end of the scope you will have multiple objects to destroy. In
And
this
yeah,
case,
then
you will
usual
have
things.
less objects, and you can optimize this exception catching.
It's really
Yeah, well-
difficult to reason about this code because we don't know what happens in Cppfront or
Yeah, I agree.
how Herb is implemented it. He doesn't even mention exceptions anywhere in this article, so maybe it wasn't on his mind even. I think his considerations were for like optimization of things more than error handling. I suspect that he might not have reached the dealing with exceptions phase in his Cppfront work. So,
But
yeah.
what other reason could be to destroy some variable in the middle of the scope?
Well, he probably means to make it easier to move the data automatically if the receiving function can actually accept like a right value references or references. But it's important to realize that in standard C++, just passing something by R value reference doesn't mean that a move has to happen. So the original object still needs to be destructed. Even though it has no value, the destructor is still going to be called.
Correct. So you would do a cd move in the function call when not advanced, but you know, whatever is the function call, and then the object will be in this unspecified state, and then the destructor will still do something, maybe nothing, but still gonna be called. So I don't know. Looking at the generated C++ would shed some light here.
So let's read what how he explains this. In this example, that call to advance with the parameter x is a definite last use of x, and so cpp2 will automatically pass x as an R value and make it a move candidate. And the call won't compile because you can't pass an R value to a cpp2 in-out parameter, which is apparently what advance has in cpp2. That's a feature, not a bug, because if that's the last use of x, that means the function is not looking at x again, so it's ignoring the out value of the advance function call, which is exactly like ignoring a return value. And the guidance is the same. If you really meant to do that, just explicitly discard x's final value. So it's not even about, optimization or moving. It's about just letting the code compile, because it won't compile with the cpp2 in-out parameter annotation.
So then it does compile when you add underscore equal x afterwards?
Apparently, yes. Because then I suspect cpp2 will not pass x as an R value by default. So an additional statement changes how this variable is passed to a previous function.
I'm not sure I like this, to be honest.
Neither do I.
Yeah, it's something that he's trying to fix in his own implementation of C++. That's what it looks like, right?
Yeah. And then listen to this paragraph. Quote, I really, really like how my C++ code data flow is explicit and fully protected and safe in syntax 2. And I'm very pleased to see how it just works naturally throughout the language, from universal guaranteed initialization to explicit constructors by default, to banning implicitly discarding any values, to uniform treatment of returned variables, whether returned by return value or the out part of in-out and out parameters, And all of it working also with the existing C++ libraries, so they are safer and nicer to use from syntax 2. That's a long sentence. Data is always initialized. Data is never silently lost. Data flow is always visible. Data is precious and it's always safe. This feels right and proper to me. End quote. So that's a lot of enthusiasm.
Yeah, let's see some better examples, not that no-op scope above, because it's literally doing nothing. So it could be optimized away completely, no movement needed. It's just, you get a value, add to it, and discard it. Okay.
He also added support for requires clauses. Oh yeah, this one is weird. Generalized aliases plus constexpr with equals. So in CPP2, declarations are of the form thing, type equals value. Quote, I decided to try using the same syntax, but with equals to denote always equal to. And the example is namespace alias, lit, namespace, equals, stud literals.
Always equal means that it's not going to change? That's what it means?
I guess, yeah. It's like context for alias as opposed to variable declarations.
Yeah.
Yeah.
It feels like Pascal to me.
And then this other chapter, safe enum and flag enum metafunctions. In short, in CPP2, quote, in CPP2, there's no enum feature hardwired into the language. Instead, you write an ordinary class type and just apply the enum metafunction. Okay. Then quote continues, why have this metafunction on an ordinary C++ class when C++ already has both C's enum and C++'s enum class? Because it keeps the language smaller and simpler, because it doesn't hardwire special purpose divergent splinter types into the language and compiler. And then, okay, I'm going to omit this Beatles quote. It's a better enum than C enum, because C enum is unscoped and not as strongly typed. And it's a better enum class than C++11 enum class because it's more flexible. Basically, you now can add member functions to enums. And a flag enum variation has power of 2 semantics and an unsigned underlying type. And the same he does with the union metafunction, which is also now sort of a class. And then he continues exactly the same points, including the Beatles thing. Yeah, so he's on fire. He's adding stuff like there's no tomorrow.
I mean, the enum problem is a real problem. I'm not sure I'm on board with a solution, but I agree that because we don't have reflections, then people are trying to iterate over enums in many ways, and we have people using macros to do things with enums.
Yeah, his enums and unions can have a toString function, which automatically produces what's needed. So yeah, that would be a plus. But this quote from Reddit. First, thanks to Mr. Sutter that at least he's trying, which is more than what others do, myself included. Next, an unpopular opinion. The more I look at CPP2, the less I like the syntax it uses. It's becoming complex really fast. And it's great that it changes, improves some things, but the ones I think are a mistake, like 6 types of arguments for a function, remain so. This will end in a complex syntax and a complex language, which will be an issue sooner than rather than later.
I think it's a very good comment. I would upvote that.
Yeah.
Especially the part, thank you to Mr. Sutter to trying, which also applies to myself, that is doing more than I am doing. So I'm just complaining about his approach, which feels very unfair, I think, in general.
Yeah, me too. We're just complaining on the internet about something that someone does.
Grumps.
Yep. Old man shouts at the cloud. And then interestingly, in the same thread, Sutter appears and says, while you're all here, let me ask a question. And then he proceeds with a bit of Reddit-driven design, gathering feedback on something he wants to do in CPP2. So recently there was an article on the LLVM blog. No, it was on libc++ documentation of the LLVM project, which described modules in libc++. They say this page contains information regarding C++23 module support in libc++. There are two kinds of modules available in Clang, Clang-specific modules and C++ modules. This page mainly discusses the C++ modules. Yeah, so Clang-specific modules have been there for a good few years now, but C++ modules are still in development as far as I know. So yeah, they list things that already work and some of the current limitations. So this is an older article than the one about CMake support. So at the time of writing this document, there wasn't no official build system support, although libc++ has experimental CMake support. And they list versions of CMake that are required for each C++ standard. This requires a recent Clang 17. There's quite a few limitations. But the fact that there's a separate page in the documentation about modules, I think it's a good sign. And yeah, it all goes toward the common goal of just simply having C++ modules everywhere. Wouldn't that be nice? There is a useful piece of C++ code on GitHub called cpp-dump. It's a convenience function, an all-around dump function library for C++ that supports even user-defined classes. It's a debug facility, a nice debug helper. So there is a macro, and there's also a macroless API, which just dumps variables to the console or whatever, to string. Yeah, might be useful for debugging. Although if you use the FMT library, the text formatting library, it already has support for dumping vectors, as far as I know. So, but this should also support all kinds of other classes. Like this is an example of what the output looks like. And then they support sets, maps, tuples, basically whatever you throw at it, it will dump.
Looks nice. Is it single header?
Probably. Like, yeah, there's, well, single header. There's quite a few headers, but it's just headers. I think there's nothing to compile, and
headers only.
Yeah. There's a single header to import and then to include, and then yeah, it's pretty simple to use. And finally, I'll leave you with this interesting article. The URL itself is interesting. HTTPS x86.mov is Turing complete. It's a paper that demonstrates that the x86 instruction is Turing-complete, all by itself. The paper starts with this, quote, "It is well known that x86 instruction set is baroque, overcomplicated, and redundantly redundant. We show just how much fluff it has by demonstrating that it remains Turing-complete when reduced to just one instruction." This paper inspired Mobfuscator, which is the single instruction C compiler. It's completely mind-blowing. Building on this, there's a branchless, move-only version of the classic Doom video game. Of course there's a Doom video game with this. It's the first thing you do.
How much did the size of the binary increase, I wonder?
Don't know about the size of binary, but the quote continues. "This is thought to be entirely secure against the Meltdown and Spectre CPU vulnerabilities, which require speculative execution on branch instructions, because they're none. The move-only Doom renders approximately 1 frame every 7 hours. So playing this version requires somewhat increased patience."
Ouch. Ouch.
Ouch. Right, that's it for today. Thank you very much for coming, and I'll see you soon. Bye.
Thank you.
Thank you, Gleb.
Thanks, Gleb.